Today's lesson, 6.6a, we'll split this into two parts. Identifying geometric sequences. So, as I've got denoted up here, another name for exponential growth or decay is a geometric sequence as compared to an arithmetic sequence. We know now from what we've been studying with growth and decay. Let's look at this definition here. We actually know a lot about this already. In a geometric sequence, the numbers are produced through the process of multiplication or division, but we really want to define it in terms of multiplication. So that number that is the pattern, that's called the common ratio. So today's goal is to try to figure out how to extend that pattern, maybe how to write some of these equations, things of that nature. Let's go ahead and get into it. Okay, here we go. So can we decide if these are arithmetic, geometric, or neither? So let's go ahead and go to it. Let's take a look at part A. What do you think? Look at these numbers here. What is the pattern here? Well, let's see here. It looks to me like everything is being cut in half. So if you're not sure what to do, remember we had talked about a little trick here. Take the first two numbers, and what you do is you divide them in reverse order. So I'm going to do that. I'm going to take 120 and 60. And I'm going to do them in reverse order. So 60 divided by 120. 0.5, and if you want to think of that as a fraction, that's 1/2. That is the common ratio. So what I'm going to do is I'm going to list that. I'm going to say that this is multiplying by half. That's got to be geometric. Let's try part B. And by the way, that is known as R, the common ratio. All right, part B. What do you think? Can you identify a pattern from 2 to 6 to 11 to 17? Well, let's think about this. If I take a pair of numbers and I divide those, then I would get 3 as a common ratio. But does that work? 6 times 3 would be 18. No, that does not work in this. No way. That is not geometric. Is there another pattern? What if we subtracted the first two numbers? 6 minus 2. That would be 4. Is that the common difference? Will that work? 2 plus 4 is 6. 6 plus 4 is 10. No, it's not arithmetic either. All right, I know what this is. This is neither. There is no distinct pattern for this. Neither. Okay? I want everybody to try, we got 3 questions here. Try numbers 1 and 2 first of all. See what you come up with. All right, so number 1, can you tell what's going on? Well, I'm guessing that I am subtracting 4 each time. And if I test that out, that does work. So that must be the common difference. That means that this one is arithmetic. That's because I'm either adding, or in this case, subtracting the same number over and over again. Let's go down to number 2. And then there's number 3 if you want to try that. Okay, let's look at this. Boy, those numbers are changing a lot, right? I've got a feeling that this is not going to be arithmetic. So I am going to test to see if it's geometric. I'm going to divide those two numbers. So I'm going to take 128 divided in reverse order with 1024. And actually what I'm going to do is I'm going to move that calculator over so it makes it a little bit easier for us to see everything at the same time. So let's see, what do we get as an answer for this? 0.125. Now remember, you can use Desmos for this if you want. That's the same thing as 1/8, either one of those. Now, does that work though? Does that work? 0.125. So I'm thinking that this is multiplying by 0.125 or 1/8. Now, I'm thinking that's a common ratio, but I don't know if that's true, so I need to test that. So let me clear this out. I'm going to put my first number in here, press equals, and I'm going to start multiplying this by 0.125. If I get this sequence, and I do, then that means, yes, this is geometric, everybody. And remember, geometric is the same thing as exponential. Just like linear and arithmetic go together, geometric and exponential go together. All right, let's try another one. Let's go to number 3. What do you think? What do you think about number 3? Is there a pattern to this? Let's see, 2 to 6 to 10 to 16. What if we add 4? Does adding 4 work? It works for a while, but then it breaks down. No. What about multiplying? Multiplying by 3? No. You know what? This one does not have a pattern. We're going to mark this one neither. Some other kind of a situation there. All right. How about this? How can you get the next 3 terms of the sequence? Well, first of all, these are geometric. That means they have a common ratio. There is a multiplication pattern. We just need to figure it out. What is the pattern here? What can you see it's times 2? Okay, so can't you just keep multiplying by 2 to get these next numbers? I think we could do that. That should be easy enough. So let's go to our calculator. You can do this a lot of ways. You can put the first number in there, set the pattern, and we should start seeing all these numbers. And we do. Here comes the next 3 numbers: 48, 96, 192. 48, 96, 192. Easy enough, right? How about part B? This one might be harder to figure out. What do you do to get from one number to the next? Remember now, this is called the common ratio. What is the common ratio here? This one might be harder to do. So maybe what you do is you take a pair of numbers and you divide them in reverse order. Okay? So I forgot what they were. I'm going to take negative 16 and 64. Negative 16 divided by 64. Okay, I'm getting negative 0.25, or as a fraction, negative 1/4. So I'm going to list that. My ratio is multiplying by negative 0.25 or negative 1/4. So if I go to my calculator, I should be able to extend this sequence. I'm going to start with 64, and I'm going to multiply by negative 0.25. Here we go. 64 goes in my calculator. I'm going to multiply that by negative 0.25. And I should start to see my numbers for my sequence, which I do. So negative 1, 0.25, 0.0625. All right, now I'm having a problem with my calculator here. Now, I could change all of those to fractions. So 0.25, or you could write these as decimals. But 0.25 is 1/4. Then you have negative 1/16. So we just got to take our time here. Okay, now You could go to Desmos and simplify those, whatever you got to do. I'm just converting them with my fraction key. You can do it, everybody. You got to know your calculator to get that done. Okay, I want you to try that on the next 4 questions. See if you can determine, just get the next 3 numbers for each one. So what I'm going to do is I'm going to bring up my calculator. I'm going to move it over here. If I can position it right there, we go. And let's get some answers for numbers. Let's do 4 and 6, and then I'll move it over. We'll do 5 and 7. Okay, so here we go. Okay, number 4. Do you see a pattern here? I'm thinking it's times 3. That's my common ratio. So if I go to my calculator and I put a 1 in there and I start multiplying by 3, if I get those numbers, I know I'm on the right track. I just need to get 3 more. 81, 243, and 729. Okay. Let's try number 6. Can we determine what's going on here? And now remember, if you cannot, take the first 2 numbers, and I'm going to divide them in reverse order. So I'm going to take negative 40 divided by 80. It's negative 0.5. So my common ratio is negative 0.5 or negative half. Can I get the next 3 numbers? I think I can. So I'm going to put my first number in, press equals. I'm going to multiply that by negative 0.5. Just verify I'm getting the answers. I am. So let's keep going. 3 more terms. 5, negative 2.5, and 1.25. What was the other one? And 1.25. I'll squeeze it in over here. Now, once again, if you need those written as fractions, let's say you're in the ALEKS program, you should have a calculator or Desmos that can change that into a fraction. Like that. I've got 1.25. Hit my fraction button. So that'd be 5/4. So you can write those decimal equivalents if you need to. Let's see how you did on the other 2. So let's move this calculator. Let's clear it out. Let's move it over here. Okay, what do you think about that? Number 5. What are the next 3 numbers of the sequence? Now they're getting smaller, aren't they? All right, what's the pattern here? What is happening? Well, if you're not sure, let's take a look at your first 2 numbers and try to establish the pattern. Okay, so let's see here. I'm going to take 500 and divide it by 2,500. And I'm getting 0.2. So what I think is that my common ratio is multiplying by 0.2. That should work. Let's just double check it. Let's put 2,500 into the calculator. Let's multiply that by 0.2. All right, there's the 500, there's the 100, and there's the 20. All right, let's get the next 3 numbers. 4, 0.8, and 0.16. 4, 0.8, 0.16, and so forth. Once again, you want to convert those into fractions? Be my guest. Do that one at a time with your calculator. Finally, number 7. Let's see how you did here. Can you tell what it is? I'm thinking that the common ratio is multiplying by -2. So I'm going to try to verify that with my calculator. I'm just going to do that one mentally. I think it's multiplying by -2. We'll start with -2, and then coincidentally multiply that by -2. Let's see if I get all these numbers. There's 4. There's -8. There's 16. Here's the next 3 then. -32, 64, and -128. And there you go. That should be the end of the lesson, and it is. Okay, everybody. Let's do the homework now. Let's do some practice.